Hello, we'll now look at inequalities with absolute values. So, as a reminder or a quick review, when we look at absolute values, we said that the notation we write them was two vertical lines, and we also said that the absolute value of A means that A is positive, or it means that A in there can be a negative. Because if we say that the absolute value of A is equal to 5, it means that this here is that minus 5, the absolute value minus 5 is equal to 5. Or it also means that the absolute value of 5 is also equal to 5. So we can think of the absolute value of some expression A, okay, as the same as if we have a plus or a minus A in there. Okay, A could be positive or A could be negative. Now, with that being said, okay, you can now think about your absolute value inequalities. Because if I have the absolute value, so if we look at inequalities now, okay, inequalities and absolute value, if we have the absolute value of A is greater than 3. Now, be very careful what's happening because I'm telling you this means plus or minus A. And if we said that that is equal to 3, then if we split this up, it means that A is greater than 3 or minus A is greater than 3. But we recall that to get A by itself, we'll have to divide by a negative 1. And when you divide by a negative 1, this inequality sign flips. So A becomes less than minus 3. Okay? So we tend to skip all of these uh, elementary steps or steps in general. And whenever we have an absolute value inequality, okay, if we have an absolute value inequality, when we split it, okay, you still have to follow the same rules for equation. Make sure the absolute value is isolated. This becomes x plus 2 is greater than 6, and x plus 2 is less than minus 6. And the reason the inequality sign flips is because of this procedure here. Okay? When we looked at equation, we just set it equal to a minus 6. But in inequalities, remember when you divide by that negative, you have to flip the inequality sign. Okay? In addition, you will see when you solve this that the graphical solution also plays a major role. So if we solve this now, we now have minus 2 on both sides. Hence we have x, the plus 2 and the minus 2 cancel, is greater than 4. And then in this case here on the other side, if we minus 2, we have x, the plus 2 and the minus 2 cancel, less than minus 8. Now, as a reminder, you should check your work. Yeah, you should always try to check. But I'm going to skip the checking because I showed you how to check in. Actually, let's do the check as the first example. If we check, remember x greater than 4, or let's look at our answers first before. If we look at the number line, because whenever we have inequalities, we should be able to express the answer graphically. If we look at 4, let's say 4 is here, x is greater than 4, so we use a parentheses and we go towards parentheses and we go towards the right. Okay, x is greater than 4. In addition, we said when we looked at inequalities that these arrows always go in an opposite direction. So at -8, okay, what you expect, and it's less than, so it's gonna go towards the left side. And as you can see, these arrows are pointing in the opposite direction. This one is going this way, this one is going that way. So it means that any number in this region and in that region will work. As an interval notation, this interval will be -infinity to -8 parentheses. This interval will be parentheses 4 to infinity. And I said to bring them together, you put the union between them. So writing it a little bit better, union 4 to infinity. So this implies that any number in this region here will work. Hence, any number in here will not work. So to check your result, okay, you can pick x to be -9 or 10. You cannot choose -8 because remember, this parentheses here means that it's not included. Okay, just past -8 is included to the left, so 8.1, -8.1. So that's why I choose 9. Or you could even try 10, okay? Or you could try x equals -10. That will also work. On the other hand, on this side, you can try x equals 5. So let's try it. Our equation was x plus the absolute value of x plus 2, okay? X plus 2, that was greater than 6. So let's try 10, okay? Let x equals -10, negative. So by doing this, we have the absolute value of -10 plus 2, and we want to know if that's greater than 6. Simplifying the inside of the absolute value, -10 plus 2 is -8, and the absolute value of -8 is 8, and 8 is greater than 6, so this is true. So that region -infinity to -8 checks. And also, if you try 5, the absolute value of x plus 2 is greater than 6. Okay, remember, let x equals 5. And if we try this, we have the absolute value of 5, okay, plus 2 is greater than 6. So we have 7 is greater than 6. The absolute value of 7, okay, and the absolute value of 7 is greater than 6. This is true. So it means that that region 4 to infinity also checks. Now, what happens if you try a number anywhere in here? Anywhere in there, you will see that that becomes false. Now let's try. What happens if we try? Let's see what happens if we try a number outside of the solution, okay, such as x equal, let's say, 0. Okay, so remember, our equation is the absolute value of x plus 2 greater than 6. Okay, let x equal 0. If x is equal to 0, we have 0 plus 2. 0 plus 2 is 0. 0 plus 2 is 2, that's 0. And the absolute value is 2, and 2 is greater than 6 is not true. This is not true. Okay? Not true. So here you see, for this solution here, you have two intervals. Okay? Two intervals in our solution. Let's look at an example again. Solve the absolute value of 2x minus 5 is less than 3. So my absolute value is isolated. There is nothing else other than the absolute value on one side of that inequality sign. So then we can split it. So this becomes 2x minus 5 less than 3, and 2x minus 5 greater than minus 3. Okay? And if we solve for x, I will add 5 to both sides. By doing this, we have 2x, the minus 5 and the plus 5 becomes 0, and 5 plus 3 is 8. And then to get x by itself, I will divide both sides by 2, and that would leave me, the 2 divided by 2 becomes 1x. We don't need to write the 1, less than 8 divided by 2 is 4. So x is less than 4. Okay? Likewise, if I add 5 on the second part of this inequality, then I have 2x, the minus 5 and a plus 5 becomes 0, is greater than minus 3 plus 5 is positive 2. Now if I divide both sides by 2 to isolate the x, okay, if I divide the positive 2 and the positive 2 becomes positive 1x is greater than 2 divided by 2 is 1. So let's see on a graph, what does this look like? On a graph, okay, on a graph, so somewhere here is 0, here we have 1, oops, 1, 2, 3, 4, 5, okay? X is greater than 1. So we use the parentheses. Greater means I'll go towards my right. Okay? And then at 4, x is less than 4, so parentheses again, and I go towards my left. As you see, the arrows are pointing in the opposite direction. This one is pointing to the right, this one is pointing to the left, and we said we can join them up together. So your solution set, okay, your solution is any number between 1 and 4, okay? So this is the inequality. This is your interval notation. This is your graphical. And if you test it, pick any number between 1 and 4 and check. So if you check, let's try x equals 2. So if we try x equal 2, remember the equation you had is 2x minus 5 is less than 3. So the absolute value of 2, we're trying x is 2, okay, minus 5, This becomes 2 times 2 is 4 minus 5. 4 minus 5 is negative 1. And the absolute value of negative 1 is 1. 1 is less than 3. This is true. So it seems that this is our answer from 1 to 4. Okay. So check your intervals to make sure, because as we saw in equations, sometimes these answers do not check out. How about we have another example? Solve the absolute value of 4t minus 3 is now greater than equal to 9. So notice that my absolute value is isolated, it's by itself, so I can go ahead and split my problem into two. We have 4t minus 3 is greater than or equal to 9, and then we have 4t minus 3 is less than or equal to minus 9. Okay. In our first part, we will add 3 to start the process of the isolating the t, and this leaves me with 4t, the minus 3 and the plus 3 become 0, greater than or equal to 12. To leave t by itself, I will divide both sides by 4. And if I do that, then the negative positive 4 divided by positive 4 leaves me with 1. So 1t is greater than or equal to 12 divided by 4 is 3. So here is what we're looking at so far. If I look at the other part of the problem, I will add 3 in both sides as I did. And that leaves me with 4t minus 3 and the plus 3 becomes 0. And then minus 9 plus 3 becomes minus 6. To leave t by itself, I will divide both sides by 4. And that leaves me with t is less than or equal to minus 6/4, which I can divide top and bottom by 2 to simplify. So t is less than or equal to minus 3/2. So let's put this on the number line. So here is my algebraic solution. On the number line, graphically, what does that look like? Well, here is 0. Okay, 1, 2, 3. 3 is here. T is greater than or equal to 3. So now, greater than or equal to, so we have to use brackets. And then since it's greater, I'll be going towards my right. Now, negative 3/2 will be somewhere over here, negative 3/2. Okay, basically it's between negative 1 and negative 2. Okay? But if you didn't do that, just don't label it. So here is negative 3/2. It's negative 1 and 1/2. And it's less than. So if it's less than, it means that my bracket and my arrow has to be going this way. And you should know that, because if this arrow is going towards the right, the next arrow will have to be pointing towards the left. So what is my answer written as interval notation? In interval wise, this arrow is going all the way to infinity, so minus infinity. So minus infinity to minus 3/2, and don't forget you have a bracket, union with from 3 to positive infinity. So graphical solution, graphical, and interval, okay, notation. And you can check your work. Pick any number, okay, less than minus 3/2, such as negative 2. Pick any number bigger than 3, such as 4, and check. Or pick a number in this region here and check it. So you can pick -1, +1. You will see that those numbers will not work. Okay. Looking at one more example, solve let's say we have the absolute value of 2x plus 3 and now plus 4, and then that's less than 9. So please observe here that your absolute value is not isolated, right? You have a plus 4. So you have to get rid of that plus 4. So to do this, we will subtract 4 on both sides. And when we do this, we now have the absolute value of 2x plus 3 is less than 5. Now my absolute value is isolated. Now it's by itself. I can split it into two problems. So on one part, I'll have 2x plus 3 is less than 5. And alternatively, I have 2x plus 3 greater than -5. Okay? Don't forget to flip the inequality sign. So if we solve now, we have -3 on both sides. So that leaves me with 2x. The plus 3 and the -3 becomes 0. 5 minus 3 is 2. And then I will divide both sides by 2. And that leaves me with x is less than 1. So if x is less than 1, you will see graphically, or you should have an idea graphically what to graph that. But let's finish up the other part. So I'm going to subtract 3 on both sides. And that will leave me with 2x, the plus 3 and the -3 becomes 0. -5 minus 3 is -8. And then I have 2x is greater than -8. I will divide both sides by 2 to isolate the x. So 2 divided by 2 is 1. So we have x is greater than -8 divided by 2 is -4. So let's look at our graphical solution. You don't have to do the graphical, but with the graphical you get the interval. Here is 0. Let's say here is 1. X is less than 1, so we don't need brackets. Less than 1. My arrow will be going towards the left. And then at -4, let's say -4 is somewhere out here, x is greater than -4. Greater than -4 means I go towards the right. As I said, you can connect those lines. So now, using my interval, I would have from -4 to 1. Okay? So that's my solution set. From -4 to 1 is my interval notation. Let's look at another problem. Solve the absolute value of 2a plus 1, and I have plus 4 on the outside, is greater than or equal to 7. So please note that the absolute value is not isolated. You do have a plus 4 here. So we have to get rid of that plus 4 to the other side. So 2a plus 1 4. So what we do, we minus 4 on both sides. If I do this, I have the absolute value of 2a plus 1 is greater than or equal to 3. Now my absolute value is isolated. I can split it and get my two problems, which is 2a plus 1 is greater than or equal to 3, and 2a plus 1 is less than or equal to -3. Okay. Add 1 and subtract 1, sorry, on both sides. So that leaves me with 2a plus 1 and minus 1 becomes 0, and that leaves me with 2. And then I'll divide both sides by 2. So we have a is greater than equal to 1. If we look at my other part here, and I subtract 1 on both sides, this becomes 2a plus 1 and minus 1 cancel, less than or equal to negative 4. 2a is less than or equal to negative 4. If I divide both sides by 2, then we have a is less than or equal to negative 2. Now let's put this on the number line to see what it looks like graphically. Okay. So somewhere here is 0. Here we have a 1. It's now a is greater than or equal to 1, so we need a bracket, and that arrow will go to the right because it's greater. And then at negative 2, somewhere over here is negative 2. Oops. Negative 2, somewhere over here. It's less than or equal to, so we use a bracket, and that arrow will be going towards my left. So using interval now, we have from minus infinity to negative 2 bracket union from 1 to infinity. So this is my interval notation. Here is my graphical. Okay. So the difference between the equation and inequalities that you have to remember to flip that inequality sign as you solve the problem. You have to remember to do that. Now, what happens if we have one of them that involves a fraction? Solve. And if I have the absolute value of 3x plus 1 divided by 2, and that is greater than 1/2. Well, the idea is the same, okay? Check to see if the absolute value is by itself, okay? If it is by itself, we know we have to split. So we have 3x plus 1 over 2 is greater than 1/2. And we have 3x, everything here is over 2, plus 1, everything over 2 is less than negative 1/2. Now, you could get rid of the fractions by finding a common denominator and multiplying both sides, okay, which is what we have learned. So, or alternatively, since you have only two terms, okay, separated by an equal or an inequality sign, we can what is say cross multiply. So you can cross multiply. What does that mean? 2 times 3x plus 1 greater than 2 times 1. Okay? And you'll do the same on the other side. Okay? You'll do the same thing on the other side. So that's an option. Okay? Alternatively, if you wanted, you could have done what we were doing before. You could also find the common denominator. Okay? The lowest common denominator here, LCD, is 4. So if you multiply both sides by 4, you will observe that this here, okay, that 4 and the 2 becomes a 2. So you end up with 2 times 3x plus 1 greater than, and the same thing will happen here. This here, when you simplify, becomes 2. So you have 2 times 1, which when you simplify, this becomes 6x plus 2 times 1 is 2 is greater than 2. If we minus 2 on both sides, then we have 6x plus 2 and minus 2 becomes 0 is greater than 0. Okay? And then to get x by itself, we will divide both sides by 6. And if we do that, we have x is greater than 0. X is greater than 0. Now, if we do the same thing here on the other side, and we see that the LCD is equal to 4 also. So if we multiply both sides by 4, we have 4 times 3x plus 1 over 2 less than, and we also have 4 times the negative 1/2. You will see that if we simplify this 4 and this 2, when you simplify, becomes a 2. And the same thing will happen on that side, that will become 2. So if you distribute, you have 2 times 3x plus 1 less than, and then on the other side, you have 2 times a negative 1. Okay? If you do distribute now, you have 6x plus 2 is less than 2 times negative 1 is negative 2. Now to isolate x, if you subtract 2 on both sides, this becomes 6x plus 2 and minus 2 becomes 0 is less than negative 4. And then if you divide both sides now by 6, if we divide both sides by 6, we now have 6 divided by 6 is 1, so that leaves me with x less than negative 4 over 6, which can be simplified by dividing top and bottom by 2. You have negative 2/3. So this here, okay, if you look at the graphical solution, of this, x is greater than 0, meaning parentheses, and we go from 0. And then from negative 3/2, so remember I said we don't really care to know exact, it will be somewhere in the left, negative 2/3, not 3/2, negative 2/3, and it's less than, so that means we have to go towards the left. Okay, so our interval notation will be from minus infinity to negative 2/3, union from 0 to infinity. So the fraction is the same idea as we were looking at before. You get rid of the fractions by finding the common denominator and multiplying each term. Okay? Make sure you multiply each term. And you know, I keep leaving out a check, but now you should check a number. Pick a number anywhere between here and see if it works. Try negative 1. You will see that that number will not work. So you should always perform a check, although I am skipping the check. I've done the check in the first 1 or 2 problems, but you should always check your answer. Mathematically, you should always check your answers. Okay?